Okay. Well, thank you for being here. Yes, my overall research program, more or less, is how to automate science. So, not very ambitious, but there you have it. So, science and pseudoscience, what's the difference? Basically, this is just a brief introduction to philosophy of science through a brief review of the history of 20th century philosophy of science. Hopefully that has some interest to you. Don't bother reading the abstract. That's to remind me of what I'm supposed to be doing. I write it in the beginning in order to direct my thoughts, and usually I ignore it, so my talk ends up being quite different from the abstract. Okay, so the demarcation problem, as it's known in philosophy of science, science versus non-science. Perhaps the first thing to do with that question or problem is to ask why ask the question? Why try answering it? I think there are two major kinds of goals for coming up with a reasoned answer to that. So first of all, there's rhetoric and politics and social arguments and so on. Classifying something as a science is, given the history of science and the history of technology, the history of civilization, it is in effect to value it, to say that it has some merit and can contribute to future society. And to classify something as non-science is not necessarily to disvalue it, but to put its contributions in some other domain. There are also methodological goals, which is probably what motivates most of the philosophers of science who have addressed the issue. That is, if we can come up with clean or reasonably good criteria to distinguish science from non-science, then in addition to just valuing something as science, we can identify what contributes to its being scientific and try to focus on those and improve those. So we're identifying virtues, identifying vices in methodology, and hopefully improve our methodological practices. So that's really the main interest for me, although I'm also pretty politically oriented, so I'm interested in trouncing global warming denialists, for example. How to proceed? The traditional approach to dealing with this kind of question in philosophy is to propose necessary and sufficient conditions and to test them. And that's pretty much what I'll be talking about as I introduce 20th century philosophy of science. And then there's alternative approaches, which I'll end up favoring. The less ambitious one just being to identify characteristics which are common to sciences, but not universal to them, hence not necessary, and possibly shared by non-sciences as well in various aspects, so perhaps not sufficient as well. So my basic answer to the question, what is science, is something like this. It is something like the organized attempt to achieve knowledge about the world through interacting with the world. So there's an empirical aspect to it, which is the interaction, which is observation and experiment. And that's the key to distinguishing it from non-scientific activities. In the Western tradition, it began with the pre-Socratic philosophers who posed various questions about what the world was made of and how it operated and proposed various answers. And in some loose sense, they were based on empirical investigations. Actually, you could take it back further than that. The Babylonians, of course, are doing astronomy through observation and so on before that. So to begin with, I'd like to contrast science with a few different kinds of activities that are not science. So first of all, just ordinary human learning. We've, so to speak, been programmed to learn through evolution. That occurred long before science existed, and hence it can hardly be the same thing as science. So we learn about the world, we interact with the world, so we learn empirically. We also have certain inbuilt tendencies towards belief and reaction and behavior. None of those things are science, but of course, They're precursors to science in a relevant sense. We wouldn't have science without those abilities. Mathematics and deduction, I would say that those are not science. They're handmaids to science. Science requires them in order to make much progress in most domains. However, the big difference, the big contrast is between deduction and induction. With deduction, you have a certain set of premises, a certain information content, and you explore that information content. Whatever you infer from it deductively is contributing no new information about the world. With induction, it's quite the opposite. You have some premises about the world, you have observations, and you hope to generalize. You hope to generate theories which will lead you to predict new observations which you don't have in your collection of belief in the beginning. And so you will infer propositions which contribute new content, new information to the body of belief. And inevitably, that means you'll make mistakes. Perhaps not inevitably, but if you do it enough times, the probability of avoiding mistakes goes to zero. So science is full of mistakes. That's one thing to understand. In particular, if somebody denigrates science because of some history of mistakes, that is perhaps misbegotten, because all sciences must make mistakes given the way what they do and how they do it. And then there's dogma, ideology, and faith, and other things like that. Those things are not science. What I say here in the detail is that they can well be a part of science. They're not incompatible with science. They simply are not in and of themselves scientific. So scientists themselves, if you go about interacting with them, can be some of the most dogmatic, ideologically driven, ridiculous people on earth. And that doesn't mean that they're not doing science, even when they're being dogmatic ideologues. What saves the day is the fact that they're in a community of people doing similar things driven by different interests, who have some agreement about the methodologies to employ and the need for empirical grounding to their work. And so their ideological dogmatic convictions get tested. They may never be converted, okay, but that doesn't matter. Science doesn't depend on any one person. Kuhn and others have observed that the dogmatists eventually die out, right? They get replaced by a whole new generation of dogmatists with different dogmas. And that's science. Okay, so a potted history of the philosophy of science. So I'll start with the Vienna Circle, or logical positivism. Outside of philosophy of science, and to a large extent even inside the philosophy of science, logical positivism and the Vienna Circle get a really bad rap. Who's heard of the Vienna Circle or logical positivism? How many people think they were really good guys? Oh man, too many of you. Okay, but at least half didn't raise your hands. Okay, so that's good. Anyway, the bad rap is something like logical positivism is all about this pointy-nosed logical analysis. It says that everything can be done through logic, and it's all formal method, it's all scientism, it's all worship of logic. And there's a lot of truth to that, but it's hardly the whole truth. Anyway, in their beginning, what they started out with was the observation that science was really incredibly successful. There have been incredible progress in science, and in the recent science, at the turn of the century, there have been a kind of accumulation of great progress, including Charles Darwin and evolutionary biology. These are some of the paradigmatic success stories of science at the time. Evolutionary biology. Logic had just been formalized successfully for the first time by Gottlob Frege, and Albert Einstein had made incredible discoveries or inventions in physics. So those are like paradigmatic success stories. And what they wanted to do was to explain those success stories, what made them successful, and and draw from them morals, if you like, for all of the rest of science. So how did that happen? So the Vienna Circle was a group of philosophers organized around the attempt to explain how that happened and inspired by those stories. So the actual beginning of philosophy of science as a discipline, as an identifiable subcategory of philosophy that talked about itself as somehow separate, would have been Ernst Mach's appointment as professor of inductive sciences in Vienna. And that was followed then by the formation of the Vienna Circle by people taught by him and associated with him. So Moritz Schlick was the actual organizer of the circle in 1922. Through the helpful activities of Adolf Hitler, all of this was spread far and wide through the English-speaking world. So the English-speaking world has a great tradition of philosophy of science from the mid-20th century, and that's directly attributable to Adolf Hitler. Because a lot of these people were Jews, leftists, or sympathizers with the same. Schlick himself was shot to death in Vienna, so he didn't get out. Anyway, here are some of the main players in the Vienna Circle. Yes. Ernst Mach, as in some sense the originator. Moritz Schlick is the organizer. Rudolf Carnap is perhaps the best known of those philosophers. Did an incredible amount of work inventing semantics and a lot of interesting work on philosophy of probability and induction and so on. Hans Reichenbach, he wasn't actually in the circle. He was in Berlin, but he communicated with them before escaping from Nazi Germany. And then a spin-off of that is Karl Popper. He was also in Vienna and participated in discussions. He didn't think of himself as a member of the Vienna Circle, but he was there, and he ended up being one of the chief critics. So Popper is somebody you may have heard of because he's very well known outside of philosophy of science, among scientists. Scientists very often, when in seminars I have very frequently over the years heard some scientists stand up and propose a particular theory, and other scientists raising their hands and saying, is that falsifiable? How would you possibly falsify it? Well, that's the falsificationism of Popper. And then another spin-off, a teacher of mine at Berkeley, Paul Feyerabend, who is a proponent of epistemological anarchism. We'll get there. Oh, and my supervisor through that interest in the mental reasons. So anyway, the Vienna Circle had a few basic principles that helped to identify them as a kind of philosophical movement. So first of all, philosophy is logical analysis, or is based on logical analysis. So they were strongly inspired by Frege and his contributions. The logical foundation of science lies in observation and experiment, so they certainly were not denying empiricism. Empiricism was at their core, so they were trying to build up the world from observation. Indeed, Carnap's 1928 title is more ambitious even than my project. I want to automate science. He wants to construct the world out of sense data. That's pretty incredible, and I think there's a universal consensus that he did not succeed. But it was a noble and also kind of sad effort. Okay, so this is what they're specifically associated with, the Vienna Circle, the verifiability criterion of meaning. So more or less at the beginning, they're trying to solve this demarcation problem. Although in this case, it's not demarcation of science versus non-science, it's demarcation between sense and nonsense. So, no doubt partly for rhetorical reasons, they wanted to claim that metaphysics, religion, superstition, all of those things are nonsense. That when you utter sentences coming out of religion, basically you're just making noise and communicating nothing. And what's the criterion? Basically, it says, what cannot be proven empirically is meaningless. So that's verifiability. If you can verify something, that doesn't mean that it is verified. It doesn't mean it has to be true to be meaningful. But if it's possible to verify, then it has meaning. And if it's not possible to verify, then it has no meaning. That's the criterion. And I've written it in symbols here. because I'll use symbols throughout because that's what I do, but I'll translate to English. So what this is saying is something like scientific hypothesis, together with some background information, maybe about experimental setup, measurement apparatus, or what have you, logically implies some set of evidence statements. Then, if it's also the case that you determine independently that the evidence statements are true, all of them, then that verifies it. So if it's possible for these things jointly to be true, then it's meaningful. Any objections? At least we get to get rid of religion. So there is progress. There is progress in philosophy. Sorry?
Can you drop that definition, however you like, of empirical?
No, not really.
Good on you.
I think I'll just kind of point at typical empirical events where you measure the angular distance of this star from that star and leave it at that.
I'm hinting at what we think is solid. It's not in between the nucleus and the surrounding cloud of electrons. There's a lot of space, proportionally as much as the space around in between the planets. It's not solid and hard. Empirically to us it's hard.
Okay, but I'm not going to claim that it's solid and hard. But I will claim that most people know an empirical event when they hit one.
Yes.
Yeah. And that's as far as I'll go. But I'll go along with Popper, for example, who says that the empirical basis is self-fallible and so on. Sorry?
That is a metaphysical perspective, of course.
Yeah, I wouldn't deny that. They would. I'm sure they would.
Can we just take questions to the question and answer just make sure we continue about the presentation? Just remember your questions and then Tony will go on.
But I was provoking them into asking questions.
He asked if anyone disagreed.
Yeah, I mean, it doesn't bother me. It doesn't bother me. And in general, I'm such an obnoxious bastard. It's very unlikely to keep us here that long.
I just wanted to make sure the questions are videoed. We weren't ready to actually video the questions while we were giving them.
Okay.
Okay, that's all. So I want to make sure everybody on the internet gets to see the questions as well.
Okay, I'll repeat questions if people have them. Okay, anyway, Karl Popper objects. Right, he pointed out, for example, that many scientific claims, statements are universal. And universal, the problem then is that you may well have an infinite number of evidential statements being implied by your hypothesis and your background information, and nobody even possibly can go and do infinitely many empirical observations, whatever empirical observations may be. And therefore, they would have to claim that this statement, not being verifiable even in principle, is meaningless, which will rule out a great deal of science. So certainly, theological positivists did not intend that. And he also pointed out that metaphysics is an ineluctable part of what we do with science. So if you just rule out metaphysics, you're stripping away the foundations of a lot of science as well. So he proposed an alternative demarcation criterion of falsifiability. Note that it's for science, not for sense. And he just said that what can't be falsified empirically, what's in principle not falsifiable, is unscientific. And his preferred examples were Marxism, where, for example, the Soviet Union didn't go through a period of capitalism before reaching the dictatorship of the proletariat, and religion and psychoanalysis. So just in this kind of pseudological notation, his claim was that you have a hypothesis, you have some background information implying some evidence, you determine separately that the evidence is false, then you falsified H. So if that is a possible state of affairs, then H is an honorable member of the scientific community as a hypothesis that's false but yet to be rejected, to put it in his kind of terms. So science progresses, alternating between bold conjectures, the hypotheses, and then refutations of those conjectures. That's what scientific progress is. And he also proposed that as a wider interpretation of what goes on in democratic societies, as long as Murdoch doesn't control all the press. So the ideal test, which he called a severe test, would be one which takes two hypotheses that are mutually exclusive, incompatible, that one of them asserts E, and the other one asserts not E. And then you go find out which one of those two is true, E or not E. And then you've got one hypothesis not yet rejected and another hypothesis rejected. So this provides a very strange concept of progress, where we accumulate non-rejected hypotheses and rejections. So the progress is just a growing heap of rejected hypotheses, which doesn't really accord very well with the common sense view of what's going on with either science or technology. So that's one reason some people rejected Popper. Can't say they falsified him, they rejected him. So Lakatos was a well-known student of Popper, or collaborator of Popper's, who came up with a different view, which he called sophisticated falsificationism. So one point is just this. If you look at it logically, Popper's claim that finding that E is false, given that it's implied by H and B, falsifies H, is logical nonsense. The correct statement is that it falsifies the combination of H and the background information. So the problem may well lie in the background information. And if you observe the behavior of scientists whose beloved hypotheses seem to have been rejected by an experiment, you will often see them blaming some of the background information rather than their hypotheses. So Popper's account is inadequate logically and also just historically, given what scientists actually do. So what Lakatos proposed as an alternative is that we should think of hypotheses not standing and falling separately, but as being bound together in a nexus of other hypotheses and theories about measurement, theories about observation, experiment, psychological theories, all kinds of related things, together with background information about initial conditions, etc. Anyway, all of these things stand or fall together, and he called them research programs. So if a research program makes novel predictions that are wholly new that no one anticipated, and at least some of those novel predictions come up true, then Lakatos blessed that program as progressive. And if a research program was swimming around in the sea of anomalies, predictions that failed to come up true, and was dominated by ad hoc maneuvers to save the central theses from defeat by pointing the blame at B all the time, then he said it was a degenerating research program. So the progressing research programs, degenerating research programs, and that's the difference. It's not the hypotheses as such that stand or fall. It's the community of ideas that a particular school or research group or whatever is promoting. So I was inspired reading Lakatos when I was young, until I reached a certain footnote, which ran on for a page and a half. And basically what the footnote said was, okay, here's an example of a degenerating research program. It degenerated, it ran into trouble, it tried to recover with an ad hoc maneuver, ran into more trouble, more maneuver, more trouble, more maneuver. Okay, well, at what point do you say, that's rubbish, you should throw it out? That's the demarcation question. When do you throw it out? And Lakatos' answer was, never. Well, you can throw it out, but there's no rational ground for throwing it out at one point versus another. If you throw it out, it's basically just a fact about your own psyche that you got sick of the program at this point and gave up. So at that point, I became dissatisfied with Lakatos, and no doubt lots of others too. So when you become sufficiently dissatisfied with logical positivism and its post-positivist alternatives like Popper, then you turn into a Kuhnian. So Kuhn started out as a historian of science, wrote a magnificent book on Copernicus, and then turned his attention to philosophy of science. So in a nutshell, his view is that philosophy of science is empty. It has no content. What's really going on with science is science changes, and in particular it changes from normal science to revolutionary science to another normal science. And those changes are driven not by normative principles and standards, but by the psychology of the scientists, by the sociological conditions, by some of them having power and others not having power, and so on and so forth. So the normal sciences is a science that's dominated by a school of thought with a particular set of hypotheses that characterize, are the core values of the science. And procedures and training standards and textbooks and stuff like that. And when anomalies accumulate, just as Lakatos described them, they do accumulate. The normal science either deals with those anomalies or it goes into crisis. And in crisis, you have an opportunity for young people in particular to come up with brand new ideas and stage a revolution and throw the old buggers out and come up with a new paradigm. So he popularized this word in this context of paradigm. So, process of science, first of all, isn't progress. It's just change. And it's not rational. At least it's not logical, but can be explained in terms of psychology, etc. So that's a kind of abandonment of the philosophical program. And then Feyerabend, he did much the same, actually. He was working with Popper in London, and then he went to Berkeley and rebelled, so I guess this is one of those revolutions, and became an anti-Popperian and what he called an epistemological anarchist. So his most infamous book is Against Method, which means what it says. So he embraced the inability to reject research programs, the fact that there's no particular point or criterion at which stage you would reject a degenerating program, and instead said that we should embrace pluralism, methodological pluralism, meaning pursuing multiple hypotheses or traditions or programs simultaneously. And he also denounced the classification of witchcraft and everything else as pseudoscience as basically just rhetorical posturing that it couldn't be explained in terms of interesting normative differences between them and science. So there we have it. Those are the extreme possible positions. You can have science is built logically out of sense data, using empirical methods yet to be defined into some huge structure, or you can have science being whatever you want it to be. There's philosophy of science in a nutshell. Philosophy has made as much progress in the 20th century as in the preceding 2,000 years. That's one way of summarizing. Okay, I would like to bring a different point of view to the issue. I apologize for the figure. I would have created an appropriate figure demonstrating family resemblance, but I didn't have the time. So we can just pretend. So one idea of Wittgenstein, he had many, most of them impenetrable, but one idea that Wittgenstein had was that natural language concepts are really open-ended, or fuzzy if you prefer, I don't care. Which means, amongst other things, that you can't get a finite set of necessary and sufficient conditions which precisely demarcate what falls in or falls outside that concept. So the idea of family resemblance is a good analogy then. If you look at families of people and compare them to people not in those families, it's not at all uncommon, at any rate, to be in a position where you have no one particular characteristic which identifies all the people in the family and distinguishes them from all non-family members. nor any set of such characteristics, meaning physically observable features. So they have certain things in common, well, but not completely. Some of the family members, it drops out, right? If you're talking about blonde hair, for example, maybe 80% of the family has it, but others have brown hair and some have red and so on. And if you look through all the characteristics, physical characteristics readily observable, then you'll discover similar things. So you can encounter a stranger on the road and just recognize that this person is indeed one of those family, one of that family, without being able to say it's precisely due to the eye color, the hair color, the physiognomy, the size of the person, or whatever. So the claim that I'm willing to push is that natural language concepts like virtue, goodness, evil, belief, knowledge, and so on are like that. That's what they're like. And science is one of those things. Well, here's another example from Wittgenstein. Game. Suppose you think you've identified necessary and sufficient conditions for the concept of game, which ought to give you some fairly precise characterization of what game rules are like. All games have rules, and we can characterize them in some way. Imagine we can characterize them in some set of necessary and sufficient conditions, but then Wittgenstein says, let's consider the metagame of playing a game with those rules. Whatever those rules are, they're not going to be able to anticipate, so to speak, that whatever you're going to do with it at that point. So you can recurse on the concept of game and force a change in the definition. And you can recurse on that concept with a meta-metagame, and you can do that forever. And so there's no fixed concept that can cover our natural language concept of game. If you look at Plato's early dialogues about Socrates, that's the game that's going on, actually. Socrates is constantly confronting this sophist or that sophist about virtue or happiness or love or whatever. And the sophist says, I know what that is. It's X, Y, or Z, or something like that. He comes up with necessary and sufficient conditions. It's always the he, of course. Comes up with necessary and sufficient conditions, and Socrates comes up with examples that violate those conditions. And in the end, Socrates can always say, now I know what we know, nothing. You can do that with any natural language concept. That's what natural language is partly about. It's about not being identifiable in terms of necessary and sufficient conditions. Okay, so science is like that. That's what I propose. That's not terribly helpful, but at least I can reject the two extreme alternatives. So, progress. Instead of assembling necessary and sufficient conditions, let's collect examples of sciences and non-sciences that we can all pretty much agree on and try to extract the family resemblances of one science to another. That's what I propose. So we can compare. On the left, I have a science. On the right, the pairings don't really matter, but I put them up there just to be suggestive. So there's physics. Physics is highly mathematical, but it's not pure mathematics. It's mathematics used to describe and explain what's going on with physical constituents of the universe, which is something mathematics doesn't in and of itself aspire to.
Applied maths.
There you go. If you want to look down your nose at physicists, you can, as a mathematician, you can say it's applied maths. Epidemiology attempts to understand the nature of disease and how it gets transmitted. It's very empirical. Medicine is very empirical as well. But there's a distinction between doing medicine and medical research. So I'm leaving out the medical research. But doing medicine on you, while it has an empirical aspect, right, it also has too small a sample size to be much of a science. It's applied medical research, right? It's medical engineering, if you like. Paleontology, attempting to understand the prehistory of plants and animals through what they left behind, versus religion, which doesn't attempt to understand them, but attempts to make assertions about them. At least some religions. Climatology versus mining.
alien miner.
I think mining's empirical in the sense that they get their hands dirty, but not in the relevant sense. Evolution theory and creationism. Okay, these are obvious, right? Economics versus politics. Of course, there's political science, but by politics, I mean things like Abbott pursuing a particular politics. Political science versus Fox News. Okay, there's lots of non-science. There's also lots of science. And we could probably do an entertaining, interesting workshop on what these things on the left have in common and what tend to distinguish it from things on the right. Okay, so issuing such a workshop, I'll just sum up what I prefer to say. The key issues are empiricism, a reference to an empirical base, where indeed the base is fallible, right? It's not sense data that you can never have any doubt about, which you logically can join into concepts a la Bertrand Russell or something. Abstraction is a key aspect of science. It's where most of the induction comes in. It's abstracting from instances, from processes, to kinds of processes, to explanatory abstract processes versus anecdotal evidence. And then there's social processes that are inherent to science as we know it. I'm certainly no lover of postmodernism and the constructivist school and those people, or Kuhn for that matter. I hate most of the philosophers I read. Even though I profit from them, I still hate them. I hate Kuhn. But he was not wrong. Of course, science is intrinsically and inherently a social process. And if you stripped away the social process, okay, you could have people doing empirical investigations on their own, but when there were ideological dogmatist nutcases, like probably at least half of scientists are, they would just shoot off into the wild blue yonder. They'd make progress on some tiny problem. They certainly wouldn't make progress on any particularly pointed problem. So it's a social process. There's psychological processes involved. There's peer review. There's stuff that gets you intersubjectivity, which is my version of objectivity. Intersubjective agreement across people, right? There may be subjective elements to it, but it is agreement. That's important to science. There is Popperian good rationality of conjectures and refutations going on, or something like it. And an alternative to that is authoritarianism.
And what was Feyerabend?
I'm sorry?
Was Feyerabend a woo-woo merchant?
A what merchant?
A woo-woo merchant.
Sorry, I
A
don't
nonsense
know.
merchant.
A nonsense merchant. What about Paul Feyerabend? Yes, he was a woo merchant. He knew it too. He presented preposterous theories about the philosophy of science. He knew perfectly well that they were preposterous, and he did it because it was fun, and because he thumbed the noses of his opponents, and he got a rise out of them, and he got a kick out of that. That's all true. Also, he was a really brilliant guy, so it wasn't just that he came up with Looney Tune ideas and stuff, but he did some amazing historical studies to support his crazy ideas, and they're very entertaining and worth reading. Okay, so I'll finish with just a couple of points about pseudoscience, since nominally this is about pseudoscience. So basically two things. The first is something I encounter all the time, and it annoys the hell out of me. Most recently, I was looking at some BBC documentary about ecology, which was claiming that ecology is not a science because it mathematizes nature and it simplifies things. There are all kinds of details about what's going on in ecosystems which can't be dealt with in their mathematical systems, in their differential equations, and therefore it's not science. The same sort of claim is made about climate science. The same sort of claim is made about the stuff I do, which I'm not going to get into. They all pursue models. All models abstract. All abstractions lose detail. So every single model you encounter in science will be false. So in some sense, Popper was right, even though he was wrong. Because he said all hypotheses, all synthetic hypotheses, universal synthetic hypotheses are false. He actually said that, which is entertaining because that's a universal synthetic hypothesis. Entertainingly false. So George Box, a famous statistician, said all models are wrong, but some are useful. So what he meant was something like what I just said. All models abstract. They're always wrong. If you're looking for one-to-one isomorphism, not just with the level of resolution of interest to the real world, but all the way down to the subatomic particle, then forget it. Nobody has that. Nobody's ever going to have that. And if that's what we needed, we would simply have to give up. It's nonsense. Einstein didn't have that, Newton didn't have that, Galileo didn't have that. And yet those things were actually useful. They were used in all kinds of ways, like building bridges and calculating how to hurl missiles at the enemy. So take any computer model, the kind of thing I work on. They're all discrete models. They are all being done on von Neumann machines, which means, for example, time is represented as discrete slices. But time as it appears to us anyway doesn't seem to be discrete. If we accept that it isn't discrete, that's another argument. I'll leave it to the philosophers of physics. Then forget it. We've lost some of the truth of reality in our models. But it's not a relevant truth most of the time. If we're doing population dynamics, predator-prey models, who cares that we're doing it at slices of 1 minute or 1 second or whatever it is? The question is whether the properties we're actually interested in modeling are preserved across time as the model progresses through time in the same way that the real system is preserving the similar related properties. That's the one and only question of interest about models. Do they track reality in the relevant aspects that we're actually interested in? And I throw this in as a little aside. Frequently you'll encounter people who demand proof. Where's the proof? And that works perfectly well in mathematics and logic, and it's rubbish in science. No such thing as proof in science. Okay, suppose a model predicts an overall process okay, but omits some tiny details, therefore it's wrong. Here's an example. So we have a time series moving along. This I presented to some students as a canned example for them to work, right? So this is a company, history of a company, so this is profit. And this is a measure proposed of competitiveness for the business. So first of all, what's the relation between competitiveness and profit? None, exactly. There's no relationship. Okay, and second of all, I do a regression to the whole thing. I get this regression line in order to predict future profit. How good is that regression line? Are you all happy with that regression line? Sorry?
Cherry picking.
No, not cherry. It's the opposite of cherry picking. I've taken every single data point and used that to generate a regression line.
Could be further data at the either end. So there's a narrow window of data. It could be a bigger window.
No, this is as big as it gets. The company's only existed for 120 years, so forget it.
You're asking how reliable is an extrapolation of it?
Yeah, exactly.
It's meaningless.
Why?
It's meaningless.
Why?
Because it's meaningless.
Well, there's a solid argument. At least they're consistent. I don't like the line either, but I want to know what's wrong with it.
Isn't it meaningless because there are too many variables in the future? Simply, and then the variables aren't being counted here, and competitiveness is too abstract.
Maybe you're putting too much weight on the label, profit, and so on. I invented the labels. So let's suppose that this is the only variable. So there aren't
The
too
whole
many
thing is
variables.
just too abstract and there's not enough variables counted.
Okay. What I would say is different. What I would say is if we look at this qualitatively, just use a kind of critical eye staring at this time series, it appears, I might be wrong, but it appears as though there are something like 3 processes happening here. There's an initial period of decline, there's an intermediate period of stasis, and there's a final period of rise. Now, if that's true, it might be wrong, okay, but if that's true, then doing a regression across all 3 is mixing 3 different processes together and pretending that you can get a future prediction out of that, which is absurd. What you really ought to do is identify cut points and say, this is where this process ends, this is where that process ends, and do 3 regressions or whatever, 3 models, predictive models as you like. It doesn't have to be regression. Regression is just the simplest and the stupidest. Okay, so I'll regress from point 80 to point 120, and what do I get then? I get that. Does that look better?
No, you don't know. It could change phase whenever. You don't know when it's going to change model.
I agree. You could turn into an elephant in just 1 minute. So my predictions about you would become quite divergent from reality. So I agree things can change. To be honest, there are 2 different ways of going about a problem like this. And the one I'm talking about now is the feeblest one. It's weak. Okay, you can just do data analysis. That's what I'm doing. The class is a data analysis class, so I was presenting data analysis techniques. The other thing is to do a fundamental study of the processes going on underneath, to look at the business, to interrogate the board, to find out what kind of business they're in, which I'm not telling you, and so forth and so on. And then you might generate a model that's richer, that actually has real content, which tells you that the business is not going to turn into an elephant in the next few minutes and stuff like that. And you would have more confidence with that. But setting aside that, how far can data analysis go? Well, I'm suggesting it can go a little bit farther than the simple regression. Get a bunch of data, do a regression, you're done. You can use your brain and decide that there's a reasonable chance that there are 3 processes instead of 1. So that might get you here. Personally, for my part, just speaking subjectively, I would say I have a lot more confidence in this projection than the first one. I think I'm not alone in the room when I say that. Okay, but let's suppose we're at a shareholders meeting and we have a minority shareholder who objects. Wait a minute. This is all rubbish. Look at this. There's no progression there. Something's going wrong. I'm going to regress just on the last 15 years or so. And then I get this incredibly low slope. And what I say is that the board of directors has done a totally incompetent job running this company. They've lost it. It's time to throw them out and replace them with superior management. What do you say to that? Why?
He has cherry-picked.
Yeah, there you go. That's right. He has cherry picked. We have a certain amount of variation going on along this time series, and that hasn't changed, where he says something has changed. That hasn't changed. The amount of variation on this regression line really isn't any different up here than down there. So there's not much evidence for any change of process there. Although indeed, if you look at the last few points and just regress there, you get a different slope. But that is cherry picking. He has a particular goal in mind, namely dumping the management. And by cherry picking the last 15 data points, he's able to get some sort of argument in favor of that. There's bound to be periods like that when you have this kind of variation going on. You can have periods of rapid rise, you can have periods of rapid fall, and they're not clear evidence of a change of process. Variation has to happen in any noisy system. So, just in case you didn't know, this is global Earth surface temperature from 1880 until a year or two ago. And this is solar energy. So I think even just from data analysis, without even knowing much about climate science, we can say, well, solar energy is irrelevant. Sorry, Murdoch. And the temperature really is rising. Now, why and what to do about it are problems for the science and not the data analyst. But the data analyst is not confused here.
If you've got an extrapolation hypothesis that works, it should work on any section of the series, and therefore you can test it against the series historically, can't you?
No. It's not the case that any reasonably justified regression will work anywhere. Things do change. There are these inflection points. They're real. If you're projecting down here and saying that the temperature, we really should be in an ice age, and that all of this stuff is just noise, right? That is highly implausible.
That's simply going to falsify your extrapolation hypothesis, though, isn't it?
No.
Surely.
No. Extrapolations go wrong. Of course they do. They have to go wrong because in a system like this that's variable, the probability of them not going wrong is eventually zero.
With any extrapolation hypothesis, then there isn't one.
No, that's not true. It's reasonable, given these data, to say that there's a process here that's reasonably consistent. Okay, it may not last terribly long in the future. Things do change. But the best prediction for the future is that this is going to continue.
I'd agree. No,
Look, basically, I think this is going back to the earlier point. There's a difference between doing data analysis on data and pursuing an underlying scientific model of the processes involved. I agree. And the science, doing science as science is a lot better than just doing data analysis on the output of some process. That's right. So I'm not making really strong claims about the projection and so on. But I am saying that the data analysis strongly suggests that there's a third process here that we're involved in, that these processes are over. And the projections from them are irrelevant to the current time. And projections from here are at least relevant. They're at least suggestive that we have some trouble here. To back that up, I would like to do climate science, except I'm not a climate scientist and I'm not going to do it. Yeah?
But we really don't know how long to project that upwards into the future, because there's an infinite number of functions that we can draw.
Sure. If you naively project it, where does the regression line go? It goes to infinity. I don't suppose that the Earth's surface temperature will reach infinity, but that's not the point.
What I mean is that there are an infinite number of functions you can draw that will put the peak of that rise at a number of different points. You can see that.
Yeah, you can do polynomial regression and get a quadratic, for example, or whatever. You can do all kinds of things. I was just doing simple linear regression. I'm not making huge claims about my extrapolation. I'm just saying that the burden of proof, I think, is on those people who say that extrapolation is going to lead us astray in the near term. I think that claim needs some support.
You almost kind of using the principle of determinate reckoning, meaning if the system was in this state for a period of time, then I will make the assumption, zero-level assumption, that it will continue in that state. You're basically saying it would be not justifiable to say there will be a turning point. It's just a dead-man reckoning kind of intuitive argument.
Well, I don't think I'd call it dead man reckoning. But anyway, regression is the first thing that data analysts use. It may be one of the weakest things as well. So I'm not putting a lot of weight on it. I'm just saying that at the very least it raises questions and puts some kind of burden on the opponent to explain why it won't extrapolate.
It's interesting when CO2 is plotted, it's high correlation. Enormous CO2 will last.
Sure, yeah, I could have plotted that as well. Runs something. Yeah.
What's missing is why it's out the window. Way back when the Earth was formed, there's a lot of bombardment by meteorites and comets. There's a lot of there. That doesn't happen anymore. It's a different process.
Yeah, of course. Processes do change, yeah.
And you could include it, but explain it by saying it's a different process.
Yep. Look, if you have independent reason that processes have changed, then that's even better than this. But here there's a non-independent reason just out of the data that the processes have changed. And you can do meaningful polynomial curve fitting. For example, with information theoretic Bayesian inference, you can do a search through possible polynomial models, favoring those with fewer parameters, but also favoring those that fit the data points well. And the combination of the two would certainly find a cut point in here and a cut point in here. Might even find a cut point over there, right? But it wouldn't be finding cut points every other jiggle. And it wouldn't be finding a cut point there. I know from experience.
What really scares the shit out of me, put on top of that, plot of methane explosion, Arctic regions, it's really scary.
Okay, but now you're talking about physical processes, which I'm ignoring. Yeah. Okay, so anyway, I guess one of my suggestions is that you can and ought to do some basic statistical analysis of available data, not in order to come up with definitive proof and so on, but in order to raise reasonable questions. This extrapolation, of course, is absurd. Anyone care to challenge me on that? Go ahead.
In your description of the board, it wouldn't be, because board members being there for 14 years would be unlikely.
No, I think boards tend to survive a bit longer than that.
CEOs these days turn over a bit.
Oh, CEOs, but I was talking about the board. Yeah, okay. If you attribute it to CEOs or something like that. If you have a particular causal theory about how the business is operating, and a particular CEO came in here, and that dive, you have reason to believe the dive is due to his or her actions, fine. That's a whole different story. Yeah.
Have you tried online trading, like trading foreign currency or things?
No. You think I should?
Yes, because you try using extrapolations to predict, future prices. It's hopeless.
Yeah, I think that is hopeless.
Both the chaotic systems, the time and
Look, I don't believe the Malkiels that of the world that Wall Street is a random walk. I think that's another brand of ideology. But at the same time, I think that predicting financial time series is incredibly hard for all kinds of reasons. And one of the main reasons is that there's so much money involved, that there are thousands of people who are expert in the area trying to do that. So I would have to be better than at least a significant number of them to make money. And I don't believe that. So I'm not willing to waste my money. Yep.
Well, actually, you could potentially say there was a company restructure at that beginning of that point.
Yeah.
I guess you could potentially say that could be true if there was a significant change.
Of course it's possible. Yeah, I was acknowledging that possibility. I was just saying that from the data alone, right, you have no good reason to infer that. You can get reason to believe that there's an inflection point, and the first time series gives you such reason. And this one or the immediately preceding one doesn't give you any such reason. Okay. To nail that, right, I'd want to do the statistics properly. And I'm not. I'm just doing hand-wavy stuff. But I assure you it can be done. It has been done. Not necessarily on this particular time series, but on similar ones.
Could I suggest that time series is not useful? A different model would need to look at the feedback model, where it's moving from positive feedback to negative and backwards and forwards.
Well, I think the time series is useful as a first cut to have an idea of what's going on. And then you go deeper. When you go deeper, of course, you get into feedback models. Absolutely. I think the Club of Rome did that, actually.
Who did?
The Club of Rome,
Ah,
back in the 60s.
Paul.
Forrester and company. They built computer models of pollution and economy and population and so on, and generated an incredible amount of heat from the right-wing press at the time. But they're still going, actually, and they're still improving their models, and that is the right kind of approach. I'm not going to say the model's right, but it's the right kind of approach. Okay, any other questions? We all happy with what is and what isn't pseudoscience? Yeah?
I just look to continuing on. Just going back to your, to that Poplarian, what do you call it, formula for describing a hypothesis. I thought that was rather cogent. But it just occurs to me that firstly the notion of empirical. I mean, you really need to be specific and say you're talking about objective observation for a start.
Why do I need to be specific?
Sorry?
Why do I need to be specific?
Because you can. I mean, surely you can use it to talk about a mathematical hypothesis within some axiomatic system. I know with absolute certainty that my triangle is only going to have 180 degrees in Euclidean space, but it's nevertheless, I can compare it with, I can measure them and see whether it actually does. So you've got...
Well, I agree that empiricism is essential to science. I'll go along with that.
I guess what I'm trying to suggest is that there are sort of generalizations from that. I mean, for example, the notion of what constitutes the fact that falsifies the hypothesis. I like the way that formula actually describes what facts will falsify the theory. But the notion that it's necessarily quantitative, I mean, your fact could simply be a logical fact. All bats are placental mammals. You're simply stating the relationship between two sets. It's not quantitative.
Okay. I'm not sure what you're getting at. So
well, I'm saying that firstly, the type of facts which you could be talking about is generalisable in the sense that it's not necessarily objectively observable facts. And then I'm saying that the facts themselves are not necessarily quantitative. They could be simply logical relations between categories. So the notion...
Okay, well, I guess basically if you're talking about a scientific theory implying a logical truism, that's fine, except that all scientific theories will imply the same truisms, and so it's not going to distinguish between them. So it's not very helpful as evidence.
I mean, on the face of it, if you're insisting that it's got to be quantifiable, you'll finish up with the sort of problem they have in econometrics, where you've got mathematics and no
Now, hang on. I wasn't insisting that hollow science be quantifiable. That was one of the things I was not doing. I was saying that quantification and mathematization are pretty common in sciences. That doesn't mean they're universal. They aren't. Of course, there's scientific work, at least, which doesn't quantify things in any particular way.
Because some physicists will sort of say, well, science is the only real, physics is the only real science, and the rest are all less standard.
People talk nonsense all the time. There are nonsensical people in every domain, including physics. Okay, so I really don't want to worry about that.
I mean, supposing somebody comes to me and tells me that they've got a meditation system, you try the following subjective method, and you'll have the following subjective approach. It's not science, but it's
well, you can investigate claims about meditation scientifically, and it has been done. There have been, in fact, supportive studies suggesting that some meditation is helpful for some purpose.
I'm talking about if somebody comes to me, I haven't got any way of looking at sort of the neural processes that are going on. I'm just simply, if you bring it to me as a person, right? And there is a kind of falsification going on there.
Okay. Fine with me. Anyone else?
Just to defend my advisor's honour.
Sorry?
Just to defend my advisor's honour.
Who's that?
Firearm.
Oh, okay.
He did actually say that the reason why he didn't privilege reason and science against the woo is because he didn't think that he was living in a time where it was necessary. So he sort of
Well, he said lots of things, and I heard him say that as well. That's right. Yeah.
Yeah. And I think he possibly would today be a little bit less anarchistic.
Quite possibly. In response to postmodernism, I'm sure he would have sent off slightly different signals. And no doubt in Socrates, Athens, he would have been supporting Socrates.
Yeah.
Okay.
In defence of Thomas Kuhn, Kuhn did say he made a number of replies to the critics, and he did counter the charge. He said he was never arguing for irrationalism. He said that even in periods after a revolution in science.
Look, he argued for incommensurability. He argued for lack of rational standards in making these judgments. If he wants to say that that's rationalism, okay, fine. But I say it's bullshit.
Right.
Yep.
I had a question about one of your slides with the panels on. It says something about refuting arguments from empirical and methods, but I can't remember precisely what it said on that panel.
Don't know that I can help you. I can just flip through, I guess. Sorry?
Early slide.
Early slide.
When we stop from asking questions. Yeah, that's it. You couldn't ask.
Here?
No,
What?
further on.
Further back or further forward?
Forward.
Sorry?
That was it.
Okay. What about this?
Just ask.
Oh, that one.
Yes, okay.
Verifiability.
What can be proven empirically is meaningless. But I mean, for instance, Leonardo da Vinci tried to prove that you could fly with a helicopter, but he couldn't make it fly because he didn't have the technology. So sometimes they think things are meaningless, but they're not meaningless later on.
Okay, but that's.
Time.
I don't believe that meaningfulness comes and goes with the tide. So I think the claim there would be that the positivists were frequently misinterpreted. They were not claiming that for something to be meaningful, it must be already verified, or we must have the technology now to verify it. But just that in principle, it is possible to verify. So the claim that we can fly is one of those sorts of things that is verifiable, even for the positive, well, even for positivists relocated to ancient Greece, where they couldn't actually go and verify it, right? But it was still verifiable. The physical.
You cannot prove something until the test.
Yeah, but that's the difference between knowing that something is so and something being so. Those are two different things. Yes.
Just a question, one of the slides further on, where you...
How far do I have to go?
The family likeness, the list of things, and then you extracted some of your considerations about family likeness. This goes to the question of measurement. I too was wondering about measurement, but I take your point. You weren't saying it's a universal for all science.
Right.
But what was your sentence to do with the empirical? Did your list have that in it?
Yeah, sure.
I'm sure it must have, but I just couldn't remember.
Yeah. Insistence on an empirical base. But of course, you can misinterpret this if you want to. When I say empirical base, I don't mean solid foundation from which you logically construct everything a la Carnap or something like that. I'm speaking ordinary English here.
No,
Okay. I'm just trying to forego misunderstanding.
There's no, as far as I know, there's no English coming.
Damn.
Damn.
I want to defend myself.
But one of the words that you had up there, which I noted was against science, was that authoritarianism, the dogmatic, the authority, which...
Well, that's non-science.
Yeah. But the way it operates is to shut down questions.
Yes.
And it seems that one of the hallmarks of science and other forms of inquiry with which it might resonate is that it enables
It encourages.
Go on being asked.
Well, more than that, it encourages
Yeah,
questions.
that's right. Well, except for those dogmatic types that you mentioned.
Well, there are characters in every field.
That's right. But I think that's right. But I think the business of encouraging, pursuing the questions, in contrast to other procedures that limit, shut down questions, I think that's a very significant hallmark.
I agree.
Of the matter.
I agree completely. I'm all in favor of critical rationalism and open-mindedness.
If everybody is willing to forego lunch, then we could stop here. I'd suggest that there. So Les knows of a really nice place in the middle of the botanical gardens. So if you follow Les to lunch, that might be a good place.
Fitzroy Gardens.
Yes, the Fitzroy Gardens, not the botanical gardens. Yeah, that's a bit far. Yes. So put your hands together for Kevin.